this exercise, we're given the nth term of some sequences. We're required to write down the first 5 terms of each sequence. Okay, so the nth term is generally written as term n. Okay, so term n is 2n plus 1. Now for n equals 1, 2, 3, 4, 5. Now they're asking for the first 5 terms of each sequence. So the first term of sequence is when n equals 1. The second term when n equals 2. The third term n equals 3. The fourth term n equals 4. The fifth term n equals 5. So they don't actually have to stipulate this. If they just say the first 5 terms of each sequence, that means you start at term 1 when n equals 1, when you go up to term 5 when n equals 5. So when n equals 1, term 1 will be 2 times 1 plus 1, which is going to be 3. So term 1 equals 3. N equals 2. Term 2 will be 2 times 2 plus 1, which equals 4 plus 1 is 5. So term 2 equals 5. When n equals 3, term 3 equals 2 times 3 plus 1, which is 6 plus 1 is 7. So term 3 equals 7. You can already see a pattern developing here. We're adding 2 to each term. So we can safely say that term 4 will be 9 and term 5 will be 11 by adding 2 to the previous term. N equals 4. Term 4 equals 2 times 4 plus 1. 8 plus 1 is 9. And when n equals 5, term 5 equals 2 times 5 plus 1. 10 plus 1 is 11. And you're going to do the same thing for B, C, D, E, and F. You're just going to take the general term and you write it like this. Tn equals 2n plus 1, or Tn equals 3n minus 2, whatever the nth term is. And you proceed to complete this exercise the same way that it's been done over here. Question 2 is pretty much the same as question 1. We're given the nth term in this exercise, and we need to find the first 5 terms of the sequence. So in A, Tn equals n plus 3. You then proceed as we did in the previous question. N equals 1, n equals 2, n equals 3, 4, and 5. Substitute n, whatever the value of n is, into the general term and find that specific term and find the sequence. It doesn't ask you for the sequence, but you're just listing the first 5 terms, and you can do that for the rest of the exercise. Okay, question 3. The nth term of the sequence is 100 minus 6n. Determine the first 4 terms and find the first term less than 0. Okay, so the nth term of a sequence is 100 minus 6n. So they're telling us that Tn equals 100 minus 6n. And you need to set up the problem as I'm doing here. Do not deviate and do something different. Set it up exactly like this. Work out the first 4 terms. So the first 4 terms, if we just draw up a table, and it might be nice to do that. So when n equals 1, let's just do it on the side here. 100, Tn is 100 minus 6n. When n equals 1, term 1 will be 100 minus 6 times 1, which is 94. When n equals 2, term 2 is 100 minus 6 times 2. 100 minus 12 is 88. When n equals 3, term 3 is 100 minus 6 times 3. 100 minus 18 is 82. And you can already see that we are subtracting 6 here. If you look at this coefficient of n, this coefficient of n is the common difference in the sequence. In other words, it's minus 6, so we are subtracting 6 from every term. So 82 minus 6 will be 76. And let's just check that. N equals 4. Term 4 is 100 minus 6 times 4. 100 minus 24 is 76. So the sequence is 94, 88, 82, 76, etc. Now required to work out the first term less than 0. So to work out the first term, we don't know what that term is. So we are required to find the nth term, whatever that term may be, that is less than 0. Okay, less than 0 implies that it's an inequality. So we are required to find n such that Tn, the nth term, is less than 0. We know what Tn is. Tn is 100 minus 6n. Now we've got a linear inequality, which we've already done. We're just solving for n. Now you need to bear in mind that n is a natural number because n represents a term of a sequence. A term of a sequence can't be a decimal, can't be a fraction. It's got to be a natural number. So we are going to solve this inequality. 100 is less than 6n. A better way to write this, as we've done with linear inequalities, is to write the variable on the left. So 6n is greater than 100. Now we'll divide both sides by 6. N is greater than 100 over 6 is 50 over 3, which is approximately 16.7. And you round it up to one decimal place. Now, as mentioned already, n can not be a decimal. N is a natural number. So the very first natural number that's greater than 16.7 is 17. Okay, so the 17th term, term 17, is the first term that is negative in this sequence. And we're going to show that now. So the sequence is 94, 88, 82, 76. Then we subtract 6 and we get 70. Then we get 64, etc. If you continue, and you're not going to do this, by the way, you're not going to continue the sequence until you get to the first negative number and then count. It's not practical, it's time consuming. So this sequence, just note for now that the sequence starts at 94. All the terms are positive. We are decreasing. We are getting smaller and smaller, but all of these terms are positive until we get to a term. And what you will get a term, the first term that will be negative will be the 17th term. So if we just find the Tn is 100 minus 6n. If we just find the 16th term, n equals 16. 100 minus 6 times 16 is 100 minus 96, which is 4. 4 is still a positive number. Term 17 is 100 minus 6 times 17. That's going to be 100 minus 102, which is minus 2. The 16th term is 4, and it's positive. And the very next term of the sequence is minus 2, which is negative. So the very first negative term of the sequence is term 17. Question 4, write down the first 4 terms of the sequence, which the nth term is, as follows. Again, this is very similar to the previous exercises. Each of these is term n, so you write it as term n equals n squared plus 2, etc. And then you want the first 4 terms, so you're going to put n equals 1 into the expression, n equals 2, n equals 3, n equals 4, and then write down the sequence. And you're going to do the same thing for question 5. It's no different, hardly any different. Number 6, a haulage company uses this formula to calculate the cost of transporting n pallets. For n less than or equal to 5, the cost will be 40n plus $50. If n is greater than or equal to 6, less than or equal to 10, the cost will be 40n plus $25. If n is greater than or equal to 11, n is the number of pallets, the cost will be $40n. How much will the company charge to transport 7 pallets? Okay, so 7 pallets is in this range. So the company charges 40n plus 25. N is the number of pallets between 6 and 10, including 6 and 10. So if we want to transport 7 pallets, then the cost will be 40 times 7 plus 25. That's 280 plus 25, which is $305. So it costs $305 to transport 7 pallets. How much will the company charge to transport 15 pallets? Well, 15 pallets is greater than 11. So for the cost will be 40n. So for n equals 15, cost will be 40 times 15, which is $600. The companies charged $170 for transporting pallets. How many pallets did they transport? Okay, so the company paid $170. Now we need to take each of these expressions here and get a whole number for n, right? So we're going to start with 40n plus 50. And if we put that equal to 170 and solve for n, and if we get a natural number for n, then we can work out how many pallets were transported. If we don't get a natural number for n has to be a natural number because we're talking about a physical quantity, a pallet. You can't have a fraction of a pallet. You have to have a whole number. Okay, it's a whole pallet. So if we're going to take each of these expressions and equate them to 170, if we get n being a natural number, we've got an answer. Okay, so 40n equals 170 minus 50 is 120. Divide by 40, n equals 3. So the company transported 3 pallets, but we're still going to check that we don't get a natural number for the other two expressions. So to further illustrate this, we're going to put 170 equal to 40n plus 25 and solve for n. So 40n equals 145. 145 divided by 40 is 3.625. So this is not applicable. You can't have 0.625 of a pallet. Okay, and the last one will be 40n equals 170. 170 divided by 40 is 4.25. And you can't have 0.25 of a pallet. That's also not applicable. I just did these two to illustrate that we get a decimal fractional value for n, and that basically validates the answer, the solution. N has to be a natural number. Okay, D. Another haulage company uses the formula $50 to calculate the cost for transporting n pallets. At what value of n do the two companies charge the same amount? Okay, so we have company A, company B. Company A charges according to the number of pallets that they have, right? So if you have less than or equal to 5 pallets, the company A charges 40n plus 50. Between 6 and 10 pallets, 40n plus $25, and more than 11 pallets, the cost will be $40n. So what we're going to do, because there's 3 charges, depending on the number of pallets that company A transports, we're going to equate each of these expressions here to company B's charge. And if we get a natural number, then that'll be the value of n where the two companies charge the same amount. So 40n plus 50, 40n plus 25, 40n, and each of these will be 50n. What we're going to do is we're going to equate each of these expressions. Now, 40n plus 50 equals 50n. Taking that across there will give us 50 equals 10n, n equals 5. So that's a natural number, so that obviously works. And we're just going to check the others as well. 40n plus 25 equals 50n. Taking that across there, 25 equals 10n. N is 2.5. You can't have half a pallet, so that's not applicable. So we make that not applicable, then validate that. And finally, 40n equals 50, and the only value of n that makes this true is 0, and you can't have 0 pallets, so that's clearly also not applicable. So n equals 5. So when they transport 5 pallets, the cost of transporting those 5 pallets is the same for both companies. Okay, question 7. The nth term of a sequence is 3n plus 7. The nth term of another sequence is 4n minus 2. These two series have several terms in common, but only one term that is common and has the same position in the sequence. Without writing out the sequences, show how you can tell using the expressions for the nth term that this is the ninth term. Okay, so sequence 1 has got term n equal to 3n plus 7. Sequence 2 has got term n equal to 4n minus 2. Now they said without writing out the sequences, show how you can tell using these expressions for the nth term that this is the ninth term. Yeah, so without writing out the sequences, what basically, if you did write out the sequences, you would say n equals 1, n equals 2, n equals 3, n equals 4, n equals 5, etc., etc. And you determine the sequence of the terms in each sequence, and then you could identify that it's the ninth term. But without writing out the sequences, we are just going to, if they have a common term, that means we can put the two expressions equal to each other. Right, if there's a common term, that means something is equal to something. So we put the two nth terms equal to each other and solve for n. So we take that term across there, 4n minus 3n equals, and then minus 2 across there, 7 plus 2, so n equals 9. And we've proven it that it's the ninth term without writing out the sequences.